So this is the next experiment of the control lab, experiment number 8, and since this is again an experiment that involves MATLAB and can be performed on computer, and the objective of the experiment given is as follows: for the given transfer function, obtain root locus, Bode plot, and Nyquist plot. So in fact, in the lab manual, the transfer function is not given, so I'll be taking an arbitrary transfer function. I will be computing the root locus, Bode, and Nyquist of that particular transfer function. So let first of all assume a transfer function, and we'll start with root locus, and I'll explain that how. There are commands for root locus, Bode plot, and Nyquist plot. I'll discuss each of them, and they are very easy. So in short, you have the command for plotting root locus is r locus, and within the braces you write the transfer function. Likewise, for plotting the Bode plots, you will be using a command Bode, B-O-D-E, Bode, and for plotting Nyquist plots, you will be using the command Nyquist. So it's very straightforward and simple using MATLAB to plot each of these plots or the approaches that we have already studied in control dynamic system analysis. So let me start with by assuming a transfer function. So let us take an arbitrary transfer function which is given by the following expression. The transfer function is t with numerator having 2s square plus 3s plus 1, and the denominator has a third order polynomial s cube plus 10s square plus 37s plus 78, and this equated to 0. The denominator polynomial equated to 0 will give the characteristic equation, and that particular characteristic equation is normally used on papers to find the root locus, Bode, or Nyquist that you all must have studied in the previous class. So there's a slight correction here, let me correct it. So now we move forward and talk about how to plot root locus first. So let me open the MATLAB command window. So as I told you that there is a very simple command in order to plot the root locus, and before that you will have to, in each cases, to plot root locus, Bode, or Nyquist, you'll have to first of all formulate the transfer function, and this was discussed in the previous lab, and we saw that how numerator and denominator are formed, and the transfer function can be written from by using those numerator and denominator. Nevertheless, I shall be, instead of defining numerator and denominator separately, because I hope that you are now quite aware that how transfer function are defined. So I'll be straightforward writing the transfer function in one line. So the command for obtaining transfer function, as was discussed in the previous lecture as well, is given as tf, and we have in the numerator polynomial things was written as, so let me show that again. So we had 2s square plus 3s plus 1. So 2s square plus 3s plus 1, so it can be written as 2, 3, 1. So this forms the numerator polynomial. Then for denominator we have s cube plus 10s square plus 37s plus 78. So denominator can be written as s cube. For this we have 1. Then we had 10s square. Then we had 37s. Then 78. So this forms the transfer function of the system, and of course we also learned that root locus, when we ever draw root locus, we consider that there is a design parameter abbreviated as k which is introduced to the system, and since this is the transfer function of a system, before introducing the design parameter to it, so the command r locus considers the transfer function of the system without the design parameter introduced to this to that system. While when you try to obtain the root locus on papers, you try to solve or you try to plot the root locus on papers, you have to consider that design parameter k. You will have to introduce it, then you will have to find the final transfer function after introduction of that design parameter. But on MATLAB we don't need to define the design parameter, so we'll move forward without defining or without introducing the design parameter. So this is the transfer function to s square plus 3s plus 1 in the numerator and s cube plus 10s square plus 37s plus 78 is the denominator. So let first obtain the root locus. So we'll draw this on a figure, let's say figure 1, and the command for obtaining root locus is r locus, as I just told you, and the transfer function is t. We defined this. So let's see how the root locus looks like in figure 1. So this is the root locus of the given transfer function. So we can observe that there are poles, 3 poles. One is here, the second is here, third is here, and then there exist 2 zeros in the given transfer function. Likewise, in order to obtain the Bode, so we again have a simple command for it. So we will be using the same transfer function to obtain the Bode plot. So we'll be drawing this in figure 2. Let us write figure 2 first. So we have figure 2, then to obtain the Bode plot we simply will write this as Bode, the transfer function t, and what we will be getting will be in figure 2, and here is how the Bode for the given transfer the transfer function looks like. So we have the magnitude on the vertical axis and the frequency on the horizontal axis, and we have the gain plot. The plot which is above is the gain plot, and the plot below is the phase plot. So these two plots, the gain and the phase plots, are collectively known as Bode plot. So this is something that we already have been discussing. Now in order to obtain the Nyquist plot, we'll draw this in the next figure, let's say figure 3, and to obtain Nyquist we simply write this as NYQUIST and the transfer function using the same transfer function that we defined above. So let's see how the Nyquist plot looks like. So this is how the Nyquist of the given transfer function looks like, and you can see that you will be having some enclosures. So the plot starts at this point, move in the clockwise direction along this figure, and then along the arrows in this manner. So this is the required Nyquist plot of the given transfer function. So you will have to submit a report, and that report will be submitted on the other classroom that had been made, not in this classroom that I have uploaded the video in. And the question, I guess, has already been floated to you, and you'll be using that the questions to submit the report in that classroom. If you have any queries and doubts, feel free to ask me on Google Classroom, or you can mail me, or you can privately post if you feel shy on Google Classroom as well.